Icing. Icing conditions are conditions in which the humidity is visible and air temperature is lower than plus 10 degrees Celsius. In stable clouds, the most favourable temperature for icing is between 0 degrees and minus 10 degrees Celsius. Icing is rare at temperatures less than minus 18 degrees Celsius. The diameter of water droplets varies, but is between 0.002 and 0.03 millimeters. When planning a flight in icing conditions, the aircraft should be equipped with an approved ice protection system. When taking off in winter conditions, the wing contamination by ice or frost will cause an increase in the takeoff distance, an increase in the stalling speed, and a decrease in the climb gradient. In public transport prior to takeoff in icing conditions, the captain must check that external surfaces are free from any ice accretion which may impede the airplane performance and manoeuvrability, except within the limits specified by the flight manual. The greatest possibility of ice buildup occurs on the aircraft frontal areas. If the engine pressure ratio probe becomes covered with ice, indications will be greater than actual. The accumulation of snow ice on an aircraft in flight induces an increase in the stalling speed. At high ambient temperatures, plus 30 degrees Celsius, and with a relative humidity as low as 40%, in air free of cloud, fog and precipitation, serious carburetor icing can still occur, but only at low power settings. Here's a graph of carburetor icing risk. The two main axes of the graph show dew point temperature on the right and temperature along the bottom. At the coldest temperatures and at the hottest temperatures, there is no risk of icing. At temperatures as cold as minus 2 or 3 degrees and as warm as plus 15 degrees, there's still a risk of serious icing when the relative humidity, which is the other scale on this graph, is above 60%. That's the red portion. You can still get serious icing on descent power, that's the yellow section, with temperatures as cold as minus 8 degrees and as warm as plus 30 degrees, with relative humidities of between and around 30 to 40%. If we look at some data for terminal VOR for outside air temperature and dew point, we can see the greatest risk of carburetor icing from those shown are those temperatures which are above zero, between plus 7 and plus 10 degrees for dew point and outside air temperature, respectively. De-icing, anti-icing. De-icing fluid is applied hot. Anti-icing fluid is applied without heating. During a de-icing anti-icing procedure carried out in 2 stages, the waiting time, holdover period, starts at the beginning of the second stage, the anti-icing stage. The application of a Type 2 de-icing fluid on an aircraft on the ground will provide a certain time of protection depending on its concentration. The greater the concentration, the longer the holdover time. An aircraft having undergone an anti-icing procedure and having exceeded the protection time of the anti-icing fluid must undergo a de-icing procedure before a new application of anti-icing fluid is applied before takeoff. Protection or holdover time. This depends on the relative humidity of the air, the type and intensity of the shower, ambient temperature, direction and speed of the wind, temperature of the aeroplane's skin, and the type of fluid and its concentration and temperature. It will vary considerably depending on the ambient temperature and the weather conditions. For a given ambient temperature, the longest protection will be in weather conditions of frost. For a given ambient temperature and type of de-icing fluid used, the shortest holdover time will be in freezing rain. The anti-icing fluid protection film can wear off and reduce considerably the protection time during strong winds or a result of the other aircraft engine's jet wash. In icing conditions and after the application of an anti-icing fluid on your aeroplane, prior to takeoff, avoid positioning in the engine jet wash or in turboprop wash of the preceding aircraft. An aircraft having undergone an anti-icing procedure must be anti-icing fluid free at the latest when it is rotating before taking off. If after anti-icing has been completed, a pre-departure inspection reveals evidence of freezing, the correct action is to carry out a further de-icing process. When an aircraft having already undergone an anti-icing procedure must be protected again, the surface of the airplane must first be de-iced again, then a new layer of anti-icing fluid applied.